Hello everyone, welcome to Kavin English Learning channel. Today I am going to teach you Basics of Computers Lesson 4. Are you all ready? Come, let's see what are the topics we are going to discuss today. As you know, system software acts as an interface for the underlying hardware system. Here we will discuss some important system software in detail. You can see hardware, system software, application software. Operating system, in short we say as OS, is the lifeline of computer. You connect all the basic devices like CPU, monitor, keyboard and mouse. Plug in the power supply and switch it on thinking you have everything in place. But the computer will not start or come to life unless it has an operating system installed in it, because OS keeps all hardware parts in a state of readiness to follow user instructions, coordinates between different devices, schedules multiple tasks as per priority, allocates resource to each task, enables computer to access network, enables users to access and use application software. Besides initial booting, these are some of the functions of an operating system. Managing computer resources like hardware, software, shared resources, etc. Allocating resources. Prevent error during software use. Control improper use of computer. One of the earliest operating systems was MS-DOS, developed by Microsoft for IBM PC. It was a command line interface OS that revolutionized the PC market. DOS was difficult to use because of its interface. The users needed to remember instructions to do their task. To make computers more accessible and user-friendly, Microsoft developed graphical user interface based OS called Windows, which transformed the way people used computer. Assembler. Assembler is a system software that converts assembly level programs to machine level code. Assembly level program, source code, assembler, machine level program, object code. These are the advantages provided by assembly level programming. Increases efficiency of the programmer as remembering minuteness is easier. Productivity increases as number of errors decreases and hence debugging time. Programmer has access to hardware resources and hence has flexibility in writing programs customized to the specific computer. Interpreter. The major advantage of assembly level language was its ability to optimize memory usage and hardware utilization. However, with technological advancements, computers had more memory and better hardware components. So, ease of writing programs became more important than optimizing memory and other hardware resources. In addition, a need was felt to take programming out of a handful of trained scientists and computer programmers so that computers could be used in more areas. This led to development of high-level languages that were easy to understand due to resemblance of commands to English language. System software used to translate high-level language source code into machine-level language. Object code line by line is called an interpreter. An interpreter takes each line of code and converts it into a machine code and stores it into the object file. The advantages of using an interpreter is that they are very easy to write and they do not require a large memory space. However, there is a major disadvantages in using interpreters. For example, interpreted programs take a long time in executing. To overcome this disadvantage, especially for large programs, compliers were developed. Complier: system software that store the complete program, scan it, translate the complete program into object code, and then creates an executable code is called a compiler. On the face of its compliers, compare unfavorably with interpreters because they are more complex than interpreters, need more memory space, take more time in complying source code. However, compiled programs execute very fast on computers. The following image shows the step-by-step process of how a source code is transformed into an executable code. Now let's see it. Source code, pre-processing, lexical analysis, parsing, complying, object code, linking, executable code. These are the steps in compiling source code into executable code. Pre-processing. In this stage, preprocessor instructions typically used by languages like C and C++ are interpreted. For example, converted to assembly level language. Lexical analysis. Here all instructions are converted to lexical units like constants, variables, arithmetic symbols, etc. Parsing. Here all instructions are checked to see if they conform to grammar rules of the language. If there are errors, compilers will ask you to fix them before you can proceed. Complying. At this stage, the source code is converted into object code. Linking. If there are any links to external files or libraries, addresses of their executable will be added to the program. Also, if the code needs to be rearranged for actual execution, they will be rearranged. The final output is executable code that is ready to be executed. Okay everyone, hope you all enjoyed and understood today's basics of computer lessons very well. So, write down these notes if you want or read these notes and study well. Thanks for watching my YouTube channel. I will meet you soon with an interesting lesson later. Bye.